Swayam Prabha, free DTH channel for education.
So in case number 2, we are going to deal with separable ODE. Okay, so I'm going to take case number 2. Okay, this case number 2 I'm going to take. So dy by dx plus p of x into y is equal to 0 is there. This one we need to solve it. So for this, what I'm going to do, so you can see that this is separable ODE because I'm going to deal that. So dy by dx plus p of x into y is there. Okay, equal to 0 is there. I can just deal that as dy by dx equal to minus p of x into y. I can deal that. Okay, therefore I can deal that as dy by dx 1 by y equal to minus p of x. I can deal, and then I can integrate that. Therefore this is going to become like 1 by y dy by dx equal to minus integral p of x dx is going to come. Okay, into dx is there. So this is going to become like dy by y equal to minus integral p of x into dx is going to come. So this is nothing but ln of mod y equal to minus e power p of x dx is going to come. Okay, so plus some constant also you can put. Okay, some constant is going to come once you integrate that. Okay, so I can put y equal to e power minus p dx is going to come. Okay, this is what we are going to do. So for this, first we need to understand. Okay, before going for this one, we need to understand some concept called separable ODE. This is the one which we are going to derive. But for this, we need to understand what is the separable ODE. In general, okay, we visit our knowledge at separable ODE. So suppose, okay, you have a function. Suppose you have a differentiation of this kind. G of y into y dash equal to some f of x is given. Okay, g of y into y dash equal to f of x is given. So in this case, so g is independent of x, it is function of y only. F is independent of x, it is function of x only. So then in that case, we call this equation as separable equation. This equation is called separable equation. We assume that f and g are continuous. So in this case, what I can do the integration over here. So this is going to be g of y into dy by dx into dx is going to come. Integrate on the other side is going to become like f of x into dx is going to come. Okay. So again, I can do the same logic. This is going to become like g of y into dy is going to come, and this is going to be f of x into dx. Okay, you can solve this problem and then you can find the answer. So some constant is going to be involved. Okay, so since f and g are continuous, this integral is going to exist, this integral is going to exist. This is the fundamental theorem of calculus. Again, you can solve this problem, and this kind of method is called method of separating variables. Okay, this method is called method of separating variables. So in this case, for example, you can take a simple problem. So you take y dash equal to, okay, let's take a simple problem. Y dash equal to x plus y minus 2 whole square, and it is given that y of 0 equal to 2. Okay, y of 0 equal to 2 is given. So in this case, what I am going to do, I am going to put a substitution here. So take d equal to x plus y minus 2. Okay, then dv is equal to, okay, dv by dx is going to be 1 plus dy by dx is going to come. Okay, 1 plus dy by dx is going to come. So therefore, what I am going to get, y is going to be, okay, y dash is going to be v dash minus 1 is going to come. I can substitute it over here. So v dash minus 1, okay, v dash minus 1 equal to x plus y minus 2 is nothing but v square is going to come. Okay, v dash minus 1 is going to be v square is going to come. Okay, also for that, y of 0 equal to 2 is given. So if I substitute it over here, y equal to 0, x equal to 0, if I substitute y equal to 2, so 0, 2 is going to get cancelled. Therefore, you are going to get v of 0, v of 0 is going to become like 0, 2 minus 2, that is going to become like 0. If v of 0 is 0. Now v dash minus 1 equal to v square. So I can write this as v dash equal to 1 plus v square, I can write it. Okay, that means dv by dx equal to 1 plus v square. So this is a variable separable, so I can write this as dv by, okay, again you got to do 1 plus v square. Okay, I am just skipping the step. okay, dy by dx, everything I'm just keeping, equal to dx is going to come. So this implies v 1 plus v square is there, therefore this is going to give you the answer for that. So that answer is going to be, you can see that, okay, 1 plus v square is there. So that answer is going to give you tan inverse, this is going to be tan inverse v, and this is going to be x plus some constant is going to come. Therefore v is equal to tan of x plus c is going to come. Okay, now v is nothing but x plus y minus 2. Okay, therefore this one I can write it as x plus y minus 2 equal to tan inverse of x plus c. Okay, so before that we need to eliminate this constant also. Okay, when v equal to 0, when x equal to 0, v is equal to 0. So tan inverse of 0 is 0. Okay, so therefore tan c is going to become like you are going to get tan c equal to 0 is going to come. Okay, so tan c equal to 0 means you are going to get, okay, so here I just write here. Okay, so v equal to 0 I got to substitute. So v is equal to tan of x plus c is there. So at 0 it is going to become like 0 equal to tan c is going to come. Okay, which implies c equal to n pi. Whenever c equal to n pi, you are going to get tan c is going to become like 0. Therefore, what I am going to get? I am going to have tan inverse of wherever c is there, I got to replace n pi. Okay, so tan inverse of x plus n pi. Therefore, you can write y equal to, so I can write here y equal to tan inverse. Sorry, this is mistake here. It's not tan inverse, tan of x plus n pi. Okay, tan of x plus n pi. So y equal to tan of x plus n pi. Okay, and I'm going to bring it over here, minus x plus 2 is going to come. So this is going to be my solution. Okay. Okay. So as I said already here, okay, so I'm going to have something like dy by dx plus p of x into y equal to 0, dy by dx equal to minus p of x into y. So you do the same job. So you are going to get ln y equal to minus dx dx plus some constant is here. Okay, I can just put here also some ln I can put. Okay, so therefore you are going to get some constant c1 into e power minus p dx is going to come. Okay, so here your c equal to e power c1 is greater than, depending on y greater than 0 or y less than 0, you got to choose your c such that c equal to plus or minus e power c1 is going to come. So here I put c1, here I so it is like. So there are two, they are constants, so you can just interchange. Okay, so in general, if I have given the initial value problem, okay, if the initial value problem is given, so in that case, what you are going to get, let us see for the initial value problem, what is it going to come? Okay, for the initial value problem, so up to here it is same. Okay, we are going to get the same thing. Okay, so we are going to get some. Let me put this one as c1. Okay, because in the slides I have given that. So y equal to is going to become like some c into e power minus integral p of x into dx is going to come. Now suppose y of x naught equal to y naught is given. So in that case, okay. So if x naught is okay, suppose y of x naught equal to y naught is given. So in that case, what you can do, you can find y equal to c into e power, okay, minus p dx is there. Here p of x into dx is there. Suppose y of x naught is given. Okay, in that case, what you can do, y of x naught equal to, this is going to be y naught equal to c into e power minus integral x naught to x. Okay, this is usually x naught to x. So, but we just keep that and we put that only x naught, because this whatever is there, it is going to be taking care of the c. So minus x naught to x naught into p of x dx is going to come. Okay, but this is already c, because this is 0. So c e power minus 0, it is 1. Therefore c is going to come. Therefore your c is going to become like y naught. Therefore my y is going to become like y naught into e power minus integral p of x into dx. Okay. So let us see that dx, okay, dy by dx plus xy equal to 0 is given. Okay, so in this case p of x is nothing but x. So therefore I can use this one, and y of 0, okay, y of 0 equal to, suppose 1 is given. Okay, then we will find whether it is going to, we will get an answer for this one. So in this case y is going to become like y naught is nothing but 1 into e power minus integral p of x is x here. So x into, okay, dx is going to come. Okay, therefore we are going to get 1 into e power minus x is going to come. x square by 2 is going to come. Okay, so e power minus x square by 2 is going to be the answer for this problem. Okay, so you can just check whether it is going to be true or not. Okay, suppose I put y of 0, that is going to become 1, so this is satisfied. If I substitute over here, this is going to become like y dash is going to become like e power minus x square by 2 into 2x is going to come. 2x is not going to come, only x is going to come. Okay, so therefore x is equal to x into y is going to come. So that is satisfied. Okay, so with this I will just conclude this today's session, and we'll discuss about the rest of the things in next class.